So this is the 2011 Section B question 6 on ellipses and so on. So the curve ABC is a parabola with vertex at B, right? So a rectangle method of drawing the parabola. The overall length is 170, okay, by a height of 130. So we have to divide up half the rectangle in this, okay. Now it needs to be divided into equal number of divisions. I'm going to choose 5 because 5 divides evenly into 85 and 130. So 5 divides into 85 every 17. So I'm going to mark 1, 2, 3, 4, 5 divisions there every 17 apart. I'm going to mark these lines up parallel to the axis of the parabola, and then I'm going to mark upwards every 26 up for the 130. 130 divided by 5 is 26. So 1, 2, 3, 4. And these points here get joined to the vertex B. So we label these 1, 2, 3, 4, label these 1, 2, 3, 4. Where 1 touches 1 is a point in the parabola, 2 touches 2 is a point in the parabola, 3 touches 3, 4 touches 4 is a point on the parabola. So we're going to draw in that parabola now. We'll start, draw a rectangular length in total 170, okay, center point at 85, okay, and height 130. So here's the axis that goes on forever. An axis is an infinite length. So 130 high then. Okay, now I'm going to mark every 17 along the bottom. So 17, 34, 51, 68. So I'm going to draw my lines then, okay, parallel to the axis. Now I'm going to mark these going upwards every 26. Careful not to go at 24 by accident. So 26, 52, 78, 104. Careful not to go at 106. I'm going to join these points to the vertex B, which is here. So that's B, that's A, that's C. Now label 1, 2, 3, 4, 1, 2, 3, 4. Where 1 touches 1 is a point in the parabola, 2 touches 2, 3 touches 3. Just do that again there. That's that line. Okay, 4 touches 4. They're points on the parabola. Then to get on the other side, I can bring my points across, straight across, take my compass, and then swing them around until they hit the line on the other side. So to get the points on the parabola on the right hand side. So it's portion BC. Do that now. Then up over your seat or untape your sheet and you can freehand sketch your points in. Okay, so you can freehand sketch them in. So I'm going to complete that now. So with that sketched in, the next thing we're going to do, so the curve DEG is a semi-ellipse with a point P in the curve. Determine the length of the minor, I should say diameter, not axis. Axis goes on forever. And draw the semi-ellipse DEG. So here we have the ellipse here. Okay, the major axis. Okay, major axis here is over 46 from B. The center point is down 60, and point P is down 38 and over 27. That's point P. Now, how we're going to solve this? We have the major diameter and we have a point on the ellipse. So we're going to essentially work backwards from the concentric circles method. We have no focal points, right? So we're going to take our compass draw in our major circle. Now, from point P, we're going to go parallel to the minor axis. So from point P, we're going to go parallel to the minor axis until it hits the major circle. And where it hits the major circle, we're going to join it back to O. Now, then from point P, we're going to go parallel to the major axis towards the sloped line. And where it intersects, that's a point on the major circle. Alright, and when we have that, alright, we can do our division of lines for the concentric circle. So 60, 30, So where the division lines hit the major circle parallel to the minor towards the major axis, where the division lines hit the minor circle parallel to the major axis away from the minor axis, and there you get points on your ellipse. So we'll begin on that. So we're going 46 there over from B, 46 millimeters. That gets D. We're going to draw in then our major axis. Now we're going to go down 60 then for our minor axis. So here's our minor axis here, down 60. Remember, we don't know the minor radius of the ellipse or the minor diameter of the ellipse. So this is point O, so we don't know where point D is. We do know where point P is. It's down 38. So it's down 38 from the center of the ellipse. And it's over 27 to the left from the major axis. So this is point P. Now we're going to take our compass. We're going to draw in the major diameter. So we're going to draw in the major diameter. That's G there. Now from point P we're going to go parallel to the minor axis until it hits the major circle. So from P we're going parallel to the minor axis towards it hits the major circle. Now we're going to join that division line, that point to O, and then for the slope line then we're going from P parallel to the major axis till it intersects the slope line. Now that's the radius of the minor circle. Then we're going to divide then our ellipse up into, or concentric circles rather, into 60-30. So where the division lines hit the major circle, we're going to go parallel to the minor axis towards the major axis. So I'm going to see the direction I'm bringing the lines at. Now where the division lines hit the minor circle, I'm bringing my lines parallel to the major axis away from the minor axis. So here are my points on the ellipse. And now I'm going to freehand sketch them in. So I've freehand sketched that ellipse in. Now the curve OS with its vertex at OR, right? So point OR, okay, how we got point OR, down 35 across there where it intersects the ellipse is point OR. So the curve OS with its vertex as OR is an identical portion of the parabola ABC. Alright, so it's OS is a portion of the parabola and it's an exact same, okay, it is the exact same curvature as ABC. Alright, draw the curve S, showing clearly how to determine point S. So this is a translation, right, from transformation geometry essentially. So going back to this one here. Okay, what I'm going to do is join B to OR. Now, from all my other points, I'm going to go parallel to line B to OR, and I'm going to move this parabola down. I'm going to take a copy of it and move it down. So I'm drawing my lines parallel to B OR. Okay, from all the points there we had picked. I'm going to take my compass, set it to the distance of B to OR. Look, I step it from each of the points until they touch the purple lines, right? And then their points on your parabola. And then to get S, you have to go down below to A, right? You have to go down below to from A. You freehand sketch all the points in, and then where the line intersects there, that's the horizontal line base intersects. That's point, what you call it, S. Right. So we have to get point OR. So we said we're going down 35 from D. So we're going down 35 from D, and we're going straight across then until we intersect the ellipse. That's point OR. Now we're going to join OR to S. Or sorry, where am I going with OR to S? B to OR rather. So I've joined B to OR. And I'm going to slide my set square and draw lines parallel to B to OR from all the points on the parabola. So put all the points on the parabola, okay, including, alright, point A, including point A. And maybe just a quick recap, if you're unsure on how to draw parallel lines, look, one way of doing it there is line your set square up with B to OR, put your T-square underneath it, hold your T-square against your desk, it doesn't have to be straight across, don't let your T-square move, okay, and then slide your set square into all the points. Now, we set our compass to B to R, right, and we mark the arcs from each of the points on the parallel lines on the original parabola ABC. Okay, so now we've got all them. We're going to freehand sketch the curve in. So we're going to freehand sketch this in. So I'll pause in a second to make sure that it's done neatly. Up out of your sheet, or up out of your desk, moving around, or untape the sheet. Now I'm happy with that curve there, so I'm not going to pause it. Okay, and then where it intersects the baseline is point S. I'll heavy it in later. The radius then, quickly do this radius here, straight down from P, compass there in the base, swing down. Right, now, next part, so the line AT. So line AT is a tangent to the circle from A, right. So first of all, to draw in the circle, straight up, straight across, drawing radius 25. The beak, the centre point, okay, or that line, middle of the beak, or not middle, I know what you call it, where the top and bottom jaw meet. Alright, 30-degree line originating from the centre and out there where they intersect, that's the tip of the beak. Then that point goes back to there, that point goes back to there. Right, that's what you call it, that on the circle. Now I'll actually get to what I was talking about, the tangent. Right. So, the tangent, right, after you've drawn in your circle, you're going to bisect this line here. So set your compass to more than half the length of the line. To make it simple for students, just set it to the length of the line. That is what they understand the most. So set it to the length of the line, swing your arcs, join your arcs together, draw in then a semicircle, and then where the semicircle pierces the circle here, that's the point of contact. That line there is the normal, that's POC, the point of contact, and here's the tangent. Alright, so I'll begin doing that. So straight over from O, here's the centre point of the circle, so literally horizontal from O, radius 25, now this is point A, so from A to the centre point of the circle, we're going to bisect that line. So compass there on A, set it to the length of the line, swing your arc left, right, put your compass then on the other side, at the centre point, swing your arc there until they intersect. Then, where the bisector intersects that line there, put your compass there, draw in the semicircle. Now, where the semicircle pierces the circle, that's the point of contact. This is the normal here, and then this is the tangent, so that's point T. So this is the tangent. Now, we're drawing the beak then. So 30-degree line from the centre point, straight across from the circle. Draw heavy that line. Join to the vertex here. Join to the vertex here. Right, now the eye is very hard to see here. You can choose your own dimension, but the eye, so that line, the circle is a tangent to that line. So from this line here, okay, we have to go perpendicular to the top jaw of the beak. So line your set square up there, hold your T-square underneath it. The T-square doesn't have to be tight against, the T-square doesn't have to be horizontal. Bring your line back to the centre point here of the circle, draw it in there. You can choose your own dimension for the eye, so whatever that is there I picked. The smaller it is, the harder it is, just for students to note. The smaller it is, the harder it is to draw in. So there's the eye there, I'll heavy in that in short. Oh well, that's happy with that. Right, now, before I start heavying in all the curves, I just want to do the front of the neck. Now, so this line is at 60 degrees from the vertex of the circle there, not the point of contact. Okay, that's very easy, so it's not 60 degrees here. Okay, and that's a very easy mistake to make. It's 60 degrees here, right? So it has to be a light line there to start with. Okay, the reason it has to be a light line is because we have to do this curve here. Okay, it's very interesting there, that little construction there. I don't know, I'll check the question there. A sec, I don't know, is that just bad printed? Okay, I think it is, right. Okay. Now, so what I was saying there was that's the beak is heavy there in between the curve, between those points. Now, back to what I was saying, right? So the radius 15 and the radius 25 circle, they're tangential circles. So 15, or the distance between two centres is equal to the sum of the radii. So they're 40 apart. Now the problem is, you don't know where this centre point is, where exactly that is. The circle, the red circle here, is also a tangent to this 60-degree line. So how we're going to find this circle? So we're going to draw a line out at 30 degrees, so it's 90 degrees to the 60-degree line. So it's, now we're going to plot out 15 millimeters on it. So we're going to plot out 15 millimeters, and we're going to draw a 60-degree line here, so these are parallel. Now, from that, we're going, the distance between two centres is equal to the sum of their radii. So we're going to set our compass to 40, and we're going to swing an arc from the centre of the big one, and where it intersects this red line is the centre point. So if you were to look at this 1 or 2 times, do so. I envisage you having a little bit of difficulty with that, if you haven't done it a lot in class. So we're going to measure out on a 30-degree line, a perpendicular line, to the tangent, the 60-degree tangent, 15 millimeters. And we're going to draw in a light line here. Now we're going to set our compass to 40, because the distance between two centre points is equal, the distance between two centres of circles is equal to the sum of the radii. So compass is set at 40, and from the centre point, swing an arc here. Okay, there's the centre point there. To get their point of contact, join their centres. So there we go. And to get the point of contact here, there's 30-degree line from the centre point, and then you can draw in the circle, or the portion of the arc. Right, so I'm going to start heading in all my drawing now. So that's the question done then. Remember, curve ABC was a parabola, the rectangle method, split it into 5s. Okay, going up into 5s because both sides are equally divided by 5. Then the ellipse, we had to work backwards from the concentric circles method. We had point P, which go parallel to the minor until we hit the major, back to O, and then bring P back parallel to the major axis to intersect it, drawing the minor. Concentric circles method, a little bit there, I forgot to heavy in, right, so I'm just going to do that now. So I drew in that portion there, ORS. Remember, ORS was a portion of the parabola. It was an identical portion of ABC. So we joined B to OR. We drew all our lines parallel, and we set our compass to B to OR, marked them along, and sketched it in where they intersected was point S. The tangent, join CP to A, bisect the arcs, okay, or bisect the line, draw in the semicircle. Where the semicircle pierces the circle is point T. You can draw in the tangent. This portion of the neck here, two circles in contact, the distance between their centres is equal to sum of the radii. So we swung an arc, radius 40, went out 15, drew a line parallel to the front of the neck where they intersected was the centre point. Cheers, thank you, bye bye.